everyone, and welcome to the newest session of Microsoft NextGen Heroes, today with the topic of Think Agentic. So basically, as you all know, today we have a very special guest with us, a person who is a big AI enthusiast, a person who really knows the AI field well, and a person who is also a Microsoft MVP, and we continue this session of MVP special guests throughout these months. So before we dig in deeply to to today's session, let's view the agenda of the day. So, as we all know, firstly, me and Marco will make a short introduction. So, for all those of you who are new to our platform and are joining us for the first time, you'll have a proper chance to meet us. Then we'll go on with Microsoft Learn. Marco will talk some stuff about Microsoft Learn, how to join our community, and also how you can join different types of learning rooms that are available in Microsoft Learn and also on Teams. Then our guest, Mr. Miodrag Cekic, will have his time and space and his part of our session to explain you our very interesting topic for today, which is thinking agentic. And finally, we'll mention some stuff about our next session, and we'll leave some Q&A space for all those of you who want to ask our special guest for today some questions. So let's go on with the introduction first. So I will go now. So hello everyone again. My name is Bojan Ivanovski. I'm a software engineering student at the University American College in Skopje. I'm also a Microsoft Learn Student Ambassador, and together with Nicholas and Marco, we're trying to spread tech vibes everywhere we go. As part of my hobbies and something that I love doing, especially when it comes to technology, I'm a DevOps, Azure, and AI enthusiast. Definitely, I enjoy working with all of these tools, and hopefully this will be the tools that will guide my career path in the future. So not to waste any more time, let's go on with the introduction to Marco.
Thank you, Bojan. This was a wonderful introduction to warm us up, all of us. So hello, everyone, and thank you for taking the time to join this session with us. Firstly, my name is Marco Atanasov, currently pursuing my degree in software engineering at Finke at Skopje, Macedonia. With the little experience I have in this IT world, I quickly found my passion and love for DevOps and the tools that are being used in the everyday by a DevOps engineer. I would also like to mention that I love being part of MLSA and Microsoft Zero to Hero because I have made a lot of lasting friendships and have improved my professional life a lot as well. I would like to also add about Microsoft Learn. I really recommend you to check this out. If you haven't joined our community yet, you can join at aka.ms join Zero to Hero. We are part of a larger organization, Microsoft Zero to Hero Learning Room, where we are around 6,000 members in the community. And it's a great chance for you to get involved and engage with the community. You only need to fill out a form and then you'll be welcomed in our learning room. In my opinion, Microsoft Learn is a great place to start your learning journey. And without further ado, I would like to keep these things short. Now I would like to introduce our speaker for today, a pioneer in the IT world, in the AI world also, Miodrag Cekic. Miodrag, welcome. Take the floor.
Thank you, guys. Thank you for the introduction. I must admit that I know you guys, and you're doing a pretty nice job. And you're truly heroes here in the community, in the Macedonian community. And I had the pleasure sharing the stage with Marco and Bojan in the last Global Azure event that was held in Skopje for the third time. Actually, it was the 13th year after Global Azure Bootcamp was established, and the third year after we participated in the Global Azure event. It was my pleasure, and there was a great topic from them about Marco and Bojan spoke about the co-pilot. how we can use it, and how we can really utilize in some cases that are from the business industry interest, and we somehow had a mutual interest in the field of artificial intelligence. And it's really my pleasure, and thank you for the invitation to be part of the NextGen Heroes season, or the episode right now, and to share something. It's a co-pilot related, but really in a way of how we can build the agent and stuff like that. Thank you for the introduction. I mean, I think that I understand something about AI. I cannot. I'm not considering myself as an expert, but I'm really trying my best in order to find a way, especially in this era and especially in this momentum. So yeah, and I hope guys you'll enjoy, and feel free to ask questions, to connect. That's the real reason why we are here and why we want to share some knowledge with you. Let me first share my screen and confirm that you can see the screen and see the presentation.
Yes, we can.
Okay, nice, thank you. So as you introduced me, I'm Miodrag Sekic. I'm a founder of Adopt Intelligence. Every coincidence is non-coincidental, as I can say. It's an AI, Adopt Intelligence. So basically it's a new company working in the field of AI and applied AI. I'm also a Microsoft MVP for Azure AI, more specifically for the Azure AI Foundry and the Azure AI Services. Actually, for the Azure Open AI Service, but now it's called Azure AI Foundry. It's my first year into the program. And I would like to say that I'm coming from a development background. So basically, I started my career as a software developer, software engineer, technical lead, mainly into the Microsoft, but not only limited to the Microsoft ecosystem. And I've done my PhD in the field of bioengineering, dealing with Python, dealing with machine learning, the traditional machine learning, as I can say, the classification, random forest, decision trees, and stuff like that. And I made a career switch. So, I mean, directly from the software engineering and going to the artificial intelligence, natural language processing part, and everything that is happening right now, probably. That's about me. So I would like to start the presentation with a disclaimer. So we all know that AI is a buzz right now, and a lot of people are just discussing AI, talking about AI. We can do this with AI, we can do that with AI, and so many AI in the AIs and in the world. But anyways, AI is not a silver bullet. The most reasonable, I think, consideration is that AI is not applicable everywhere. In fact, the first condition or the baseline is the data. So basically, you have to have great data in order to provide a great AI or a baseline or a foundation for implementing an AI. Even in such cases, in some scenarios, AI is not the way to go. So probably traditional software engineering techniques are applicable for solving a challenge. So as a disclaimer, we are not using AI just because we want to be fancy, but we are using AI just to be just to help us or be a tool or complementary framework to what we want to do, and want to do it like more performant and more efficient. And the next one is like, are you hyped, guys? So I would like to ask Marco and Bojan just to interrupt the presentation. And I'm really curious if you're hyped about what's happening right now. How do you feel about this right now?
I mean, definitely the hype is everywhere, all around the world. We really see the potential in AI agents. So, and we are excited to see what will happen in the next coming months. I mean, probably the world is going to change, in my opinion, and how
Yeah,
we
I
work.
totally agree with Marco. Like, there's a lot going on now, and I cannot imagine what's going to happen in the next few years. So I'm really eager to see what this new agent AI era will bring to us, and hopefully it will be something amazing, like this session for yours.
Yeah, so you're hyped, guys. So thank you.
Basically.
I get the same impression. We were on an MVP summit, and we met Scott Hanselman. And there was one panel discussion. It was really insightful discussion. and the moderator asks Scott Hanselman about, do you feel, that the AI is like overhyped or underhyped? And he said like it's definitely hyped. And I can share the same. I'm sharing the same opinion, because it's definitely hype. It's definitely a buzz right now, but it's not something that is really coming right away right now. So AI has history, and AI is coming is dating back from 1950s. But now I guess it's the time for democratizing AI, and probably be one of the technologies, the disruptive technologies that will somehow mark this era. And it's probably a window of opportunity for all of us to just enter it and be more performant and do some stuff that was like impossible to do probably 10 years ago. But before everything, I would like to just really briefly discuss some action points or some trends that I realized, and how I'm just analyzing the things when it comes to the AI. So basically, this is the graphic that showcasing that the ChatGPT went to 100 million users in almost 2 months. And that happened like in 2022, in November 2022. And the underlying model was the GPT 3.5 Turbo model. And that was like the boom. Everybody were like, oh, this is great technology. I mean, part of the people were like, this is a great technology. But there was a significant amount of people, like they said, okay, this is nothing new, or this is something that is expected to be here, or stuff like that. But 2 years ago, when I was discussing this, when I was presenting some and delivering some sessions, I said that it's just the beginning, because a lot of players are in the same market, and a lot of players are going to build something similar, even better, or probably are going to specialize the models in different areas. And it's happening right now. So basically, we can see a lot of vendors, a lot of foundations, a lot of organizations, a lot of individuals, a lot of people in the same area building different large language and small language models, dealing with different natural language processing technique, and producing fine-tuning establishing or fine-tuning models that are really changing our world. On the other hand, I'm really interested in what's the most interesting thing in the world. So how the people are just consuming this technology. And I'm really often going through the interest rate on the Google searches. So for generative AI, we can see the peak right away when the ChatGPT was released. So that was like, let me get the laser. So that was like the end of 2022, November 2022, and then just a spike upward. And then we can see something else. So here is the ChatGPT release. We can see that at the end of 2023, another concept emerged, and that was the concept of the agents, or to be more precise, the functional calling concept. And that was the concept where there was done engineering into the around the model, so they can be used for building actionable applications. And a lot of people said, again, the opinions were divided, like this is like really emerging technology and this will change the world, and other guys were like, this is nothing, there's nothing new in this world, and it's gonna be here, but it's gonna be another tool or framework or so. But again, this is just one puzzle, and we can see that we are witnessing today that there's a tremendous part of the world, or the ecosystem, AI agent ecosystem, that is emerging right now. And a lot of applications are built within and on top of that in different business domains and for different purposes, like coding assistants, like chatbots specialized for finance, chatbots specialized for law enforcement, chatbots specialized or assistants specialized for creating presentations and so on, or deep thinking or reasoning and stuff like that. And that actually guides me to the interest rate and the searches on the Google. So we can see that after some time in 2023, so now the image is like zoomed out, and we can see the trend of AI engines is like, it's going like getting to the peak and still vibrating around that peaks. That means that interest over time in the world is definitely high when it comes to the AI agents and to the generative AI. generative artificial intelligence. And here we come. This is something that I'm presenting for a while. This coming from Menlo Ventures, and this is showcasing the adoption rate of all these disruptive new technologies. I mean, all technologies that change the world, de facto change the world. One of them is like the mobile. So the mobile technology, as you can see from the graph, is like that's the technology that changed the world from day zero. Why? Because all of us just wanted to have mobile phone, and that's a fact. I mean, even if I go back to the first prototype and the first mobile phones, everybody were just hyped. This is it. I'm gonna call everybody from my pocket. So that's the adoption from day zero. On the other hand, we have the internet, the cloud technologies. We all know how the cloud was developed, and the generative AI. And the generative AI forecast, I mean, the bull case, how it will go around. So we can see that it is really closely to what internet done to the world. But there's one little thing that is so significant on this graphic, and that's the third year. So as you all can see, that starting from the third to the fourth year, here is the time where the graph is like exponentially going up. I mean, the trend is to go up. We don't know how it will go. And basically, if I go back to the previous slides, I said that ChatGPT was released November 2022. Now we are like converging to the November 2025, which means we are going really close to that third year. And I expect, and a lot of people expect, that it will be the year where these technologies are going to be more and more adopted and going to explode and really be part of our daily lives as software engineers, software developers, and anything AI, IT or non-IT related. But we can all agree that this is a rabbit hole. So a lot of information, a vast amount of information about AI, and a lot of people right now. I'm communicating with a lot of people here in Macedonia, not just in Macedonia, and a lot of people just asking where to start. I mean, there's so much information. What's the right way to start and to understand how to get the foundation, how to learn the fundamentals of what's happening and how to utilize it and get the most of it. So basically, that's the real deal today, and I'm gonna talk about how we can think agentic, and I'm gonna guide you how I progress from what is called a retrieval augmented generation principle to the agents. So basically, the retrieval augmented generation, which is a RAG, something that emerged right away after GPT was released, is generally a concept or an idea where we have the models like here, but the models in that system or the design pattern are the end instance of everything. So basically, we're using the generic knowledge, and we are admitting that we know the power of reasoning over the data for the models. We know that they are specialized in reasoning. They can really predict the next word very well. And we are using them injected to the pipeline where our data is actually stored. So basically what we are saying, okay, I have a database, I have different files, I can have different systems, so I can collect my data, structure my data, organize my data, doesn't matter. And there's a concept of vector search. So basically, when a user asks something or looks or is looking for some information, what is happening right away is like we are doing a similarity search throughout our data and providing back to the model only the data we are interested in. So that's why it's called like retrieval augmented generation. We're augmenting the information. And basically, we're using the generic knowledge of the model to reason over our data. So that's not fine-tuning. That's not training of the model. That's using the model out of the box on our data. And that principle is still very famous. A lot of people are using it. I'm personally using it. And it's part of the industry. A lot of systems are like done on that way. So basically, what's happening behind the scenes is like we are storing the data, chunking the data, in multiple chunks. We are vectorizing the data, storing in a vector store, and doing a similarity search using different algorithms, different techniques, and providing back what's the most similar for what the user is looking for and reason over that data. The art here is how you're gonna design this pipeline, and the system accuracy and relevance will really depend on how you're gonna structure this part and how you're gonna organize your data, rather than the choice of the language model. On the other hand, now I'm talking about the data, but it's not that you have a text-based data or you have a database with a structured data. This thing is getting bigger and bigger. So besides the data that can be injected like raw data, as I can say, there is something in the Microsoft AI portfolio which is called AI services, or they used to be called like cognitive services. So basically, these are the vision, the speech, the language services, the document intelligence, or AKA form recognizer. So these are all services that are providing high-level artificial intelligence out of the box, which means, for example, for the document intelligence, we're going to not build optical character recognition algorithm from scratch. We're going to use this technology incorporated within the document intelligence service, and we're going to extract content from images, from tables, and so on, and so directly into the our solution. It's the same situation with the text-to-speech, speech-to-text for the vision models, and so on and so on. So we are witnessing a democratization of AI, like we have cloud-native services that are providing artificial intelligence behavior on a high level. So we are not dealing with the low-level stuff, just using these services in order to provide data to the system. And these services can be really glued or injected to the pipeline I already mentioned. Is related to the retrieval augmented generation. And how the architecture looks like. So we are now converging to the agentic part. So basically, starting from this slide, we are thinking agentic. So we have the models, we know about retrieval augmented generation, and we are saying, okay, if I can inject data with the retrieval augmented generation, why not inject something actionable to the system, and why not just grow that data set possibilities that the system can reason over them. So basically, right now we have some application or the UI, and we have the query function which is coming from the user. Basically, part of these slides, just a disclaimer, are coming from the season of agents. It's the 4th edition right now. It's happening all around the world. So basically, part of the slides are from there. I'm going to share a link to the GitHub repository so you can access the slides. You can access a lot of code there, and you can also follow all seasons for the agents and how we're going to build agents in different seasons and for different specialties. And then after the user interface, we have the Azure AI Agent Service, or the Azure AI, in fact, where the instructions and the models are. I'm going to show that in the demo. And now we are discussing about not just file search, not just about retrieval augmented generation, but also connecting to services like the Bing search, so we can crawl the internet right away, real time. We can talk about services like code interpretation, so we can inject to the system scripts like Python script, and we can guide the system to use the script if needed, if that's what the user is looking for. And also any kind of functional calling, which are basically any APIs, any functions, any methods, any logic app integration, and anything you can imagine, like an API to API integration that will bring data, to channel data to the system. But there is one thing that I would like to emphasize here, that the concept of function calling can be really easily misunderstood, because the models, like the large language models, if you're using like the GPT-4 model, they are not executing anything. So they're not supposed to autonomously call any action, but they're working with something which is called a structured outputs based on JSON files or a JSON structure. They can recognize that something can be executed, but it's up to the code, to the framework that we are using. Today, I'm going to show something with the semantic kernel, but it's up to the framework and to the engineering wrapper around the models to execute that actions and provide back the results to the model. So again, even in the agentic world, which is like something on the top of what I've mentioned about the retrieval augmented generation, we still put the large language model or small language model or the natural language model, the model itself, as an end instance to the system. That's really important to emphasize here. And what's agent after all? I mean, what's the definition for agent? It's really interesting that if you go by definition, you'll see that the semi-autonomous software that actually not know in advance exactly how to execute something. That's what I'm talking about. That it is a system that can recognize actions that can be executed to satisfy user demand, but they're not aware in advance about what they're gonna do or what they're gonna provide to the user. That's the difference between the traditional software engineering execution flows and what's happening right away here. Also considering that the large language models has like the stochastic nature of execution, and they are like built with deep neural networks and everything in that area. And what I would also like to showcase is that now having the agents, we don't have just the possibility to reason over a business process or to retrieve a context about some process, but we also have the possibility to make the application or the systems actionable, so that the user can also experience actions during the execution flow. Before going to anything, in a technical way into the demo, I would just really briefly would like to showcase the agent components. So basically, we have the agents, and you can imagine the agents as the models itself and the instructions. So it's basically like system prompt and the model. That's basically the agent. But behind the scenes, there is a concept called thread. And each thread is particularly a connection, an ecosystem where the user is communicating. So basically, each thread is represented by multiple runs, and each run is actually the conversation interaction between the user and between the system itself. Why the system? Because the system can be represented with different actions that can provide data to the agent itself, and then the reasoning is happening and the results are back to the user. So basically, we're talking about threads, and within a thread we are talking about runs that can be represented by different calls to the functions, to the APIs, to the code interpretation, to the web search using search services, and so on and so on. And in more general details, I mean, like a burst perspective of everything, is the EA agent service in action, which is basically, I will showcase right now directly on the Azure cloud how you're gonna create an agent, how we're gonna experience the thread, how we're gonna run the agents, and how we're gonna see they are working with different data providers, as I can say, to the system. As well as I will showcase how we can attach an code interpretation tool, and also Azure AI Search Index, so that the data can be retrieved from various resources, and the language model can reason over various scenarios for a particular case. And as something that I would like really to emphasize during the presentation is the semantic kernel, which is an open source framework for orchestration of the agents. I'm going to showcase the semantic kernel just because I would like to give you a broader perspective how you can use the agents. So we can create agents, we can create one single agent, and we can provide to that agent 10 different sources of data, like code interpretation, different indexes of data, different functions, APIs, and so on and so on. But that's the same, like, if I can say, like, okay, guys, I have 10 different books about software engineering, and I can provide that books to you. And then I can ask you about how we can implement bubble sort or simple sort, or how we can create a clean architecture for web application. So I'm sure that you're going to find that information and you can interpret that information. But if you have like 10 books, it will take some time. Or probably if you have really similar books about software engineering, it will not just take a time for you to find the information, but you'll need time to reason and to find the exact information which is related to the question itself, or probably to reason over multiple sources of data and provide back the accurate information and to answer that response. So basically that's the same with the agents. If you like overkill the agent with different endpoints and data, like over 10 or 15, doesn't matter, even and going even more, like different sources of data that are similar or close to each other, then the probability for the agent to provide back general knowledge or general answer, or not specific answer, or probably something really different from what we are expecting, is really high. So that's why I would like to emphasize the semantic kernel, which is a kernel as a central core unit, and it's used for orchestrating agents. So in that manner, I will showcase how you can create agents that are specialized in different business domain, but they can talk and understand between each other. And I'm going to talk about two different approaches. The first one is, like, I called it like shared context strategy. The another one is the orchestration design by definition. I'm going to show two different demos. The first one is about if I want to learn about some concept. For example, I will showcase I have data for I want to learn a semantic kernel or any concept. So I can crawl the web a little bit and then create an index with that data. And I can create a system that consists of 4 or actually 3 agents. The first agent is the planner agent. So I can ask the system, I want to learn about semantic kernel. And the system is able to take that prompt, to extend that prompt, to purify that prompt, to enhance that prompt, and to ask me if I'm sure about that. I will show you that in the code and in the demo. And then it is sending the information to the planner agent. The planner agent is dealing only with creating learning plan. So I have the material and I want to learn about that. The planner agent is specialized to create a plan. How should I do something? And then it is stored under correlation ID in MongoDB. It can be Redis, any cache store. It can be Azure Service Bus, anything, guys. Then if you have a plan, you have, I'm always saying, like, plan without execution is nothing. So idea without realization of that idea is nothing. So basically I have another agent which is called executor agent, and he's constantly checking if there's something to be executed. So if the executor agent finds some plan, then he's doing the execution steps of that plan and is providing results around that concept. So basically it is taking the action plan from the planner agent. It is creating an execution plan and providing back feedback to the planner agent that it has done that. In the meantime, the executor agent is able to directly call explorer agent, which is able to crawl the internet and provide back URLs and data that is significant or relevant to what we are talking about. So basically, we are creating action plan, we are creating execution plan, and we got an exploration of the execution plan, which is fulfilled with URLs from where we can learn some topic. On the other side, we have a conductor orchestration design, which is more in a way that I have an application, Flask API application, that is orchestrating all the stuff based and built on the top of semantic kernel. And I will showcase how you can create prototypes of applications using different agents in this manner. Like, let's say you have some idea. I want to build application for 3 dots. You can imagine. You know what you want to build. But if you go to in a traditional approach, you're always saying, like, oh my God, I need to create a business plan. I need to create a specification. I need an architecture. I need someone that is working with Angular or Vue.js or React. I need some guy that is working with backend. What would be the backend? Python or C# or Java or anything. And then you need someone that is going to be dealing with the continuous integration, continuous deployment, the deploy part, which is the DevOps, and so on and so on. And it will take time. a lot of time before you see your idea digitalized as a web application, mobile application, or anything you have on your mind. So that's why I've created something that I named like conductor orchestration design, or a framework that is enabling me to provide an idea. So here I'm providing an idea to the system. And then what is happening behind the scenes is like an orchestra of AI agents. So basically that idea is taken by a specification agent, and he's creating the specification or functional Jira requirements for that idea. And then it is sending the information to the architecture agent, which is creating the architecture and is creating how it should look like based on the instructions. I'm dealing with a Python Flask application. So the architecture agent is structuring the architecture based on some principle that can be explicitly stated or not. And then in parallel, we are activating two agents, the backend and the frontend, and they're really developing, like providing the code for the applications. As soon as they finish, they provide the result to the DevOps agents, which is dealing with the Terraform scripts or any continuous integration, continuous delivery stuff that you want to do. And in the end of the day, the most important one is the prototype agent, which is creating the prototype of your idea. So basically, in a couple of minutes, I will showcase that. You will have something digitalized. You will have your idea digitalized. You can place that idea on the market. You can present that idea to potential investors. You will have something out of nothing based on such a framework or such an orchestration, so that you can really try and continue building the idea itself. And it's time for demo right now. I guess that I shared this screen. Yes, okay. So let me first go to the Azure portal. Can you just confirm me that you can see the portal and you can hear me well?
Yeah, everything is good.
Okay, guys. I'm gonna try to be as much as effective as I can right now. So basically, I want to build an agent. We need to go to the Azure OpenAI, and I'm gonna select this instance and go to the Azure AI Foundry, actually, which is something that will link me directly to the Azure AI Foundry. And I'm gonna try to build an agent and showcase you how it works. So basically, if you go to the Azure AI Foundry, there's a place for the assistants. So this is the traditional look like of the Azure AI Foundry. It looks like the Azure AI service, Azure OpenAI service. But here is the Azure AI Assistance part, which is still in preview. And we can try it by just let's go to try the Azure AI Agent service, which is basically this one. So if you hit here, it will ask you for the project. I have the project AI Agent Showcase, selected it, and it is directing me to the Agents Playground. What I would like to showcase here is like there is the model catalog here. So basically, you can work with different models, not just the models that are like GPT or OpenAI, but there are like few models from Microsoft. It's the place for DeepSeek, Cohere, Stable Diffusion, Mistral, anything you can imagine, guys. So basically, in the model catalog, there's support for a lot of models from where you can build your applications. If I go to the agents part, I have some data about, I'm going to show you the data right now, about the today's session. So this data looks like this. I have the Microsoft Zero to Hero community data. That's the data. It's on the other screen. I'm going to showcase right now. So this is the data about the community itself, and another file about the session that we have right now. So basically, the session, I'm the speaker, and something about how I'm going to deliver the session. And this is the data I just created with the GPT, nothing special. This data is part of the files or that retrieval augmented generation principle I said. So basically, it's part of a vector store, and I'm going to add to the agent that vector store. I'm going to say, okay, I'm going to use an existing vector store, and this is the NextGen Heroes store, which consists of these two files. And I'm going to add that files. And now, this agent, which is working with the GPT-4 mini model, is not just aware about the general knowledge of the GPT model itself, but it knows about this session today. So we can ask question about that. Besides that, what I would like to show is that we have the possibility to also, I said that we can provide a possibility for executing scripts. So if I open this script, not in Notepad++, but probably in Notepad here. Okay, so I have a script in Python which is analyzing feedback, probably you and hopefully your feedback about this session. And I want to get the sentiment analysis and some stats about how people actually like the session. And also I want to plot some stuff regarding these calculations. So it's a Python script. And this is not that something that the model knows itself by default. You can guide the model, but still, this is something that I've created by myself. So let's put this script as another action to the model. So the model can execute this script. And I can say, okay, this is the lecture analyzer. And just be aware that we have a script as well. So I can say here, like, what is Miodrag doing during the NextGen Heroes episode today? I can ask this. And then the agent itself is like, you see, looking for references and it's trying to find something that is in the file search. So basically into the vector store or the vector we've created with that file. And this is here. And it is also referencing the file. It's the NextGen Hero session details file about where we mention details. And I'm going to showcase here that what the system is doing is like we have the thread. I ask something, we have the run, and in the run step, we are calling a tool. So that's why it's calling the functional calling or the tool calling. So basically, the system recognized that we have that data and executed some similarity search, provide back the results from that file, and reason over that results and provide back the information. What is actually Miodrag or I'm doing right now here. On the other hand, I would like to showcase the script itself. So basically, I'm going to go to the spec data or here. I have the prompt here. I will showcase that. Here is the prompt. Here is some comma separated value feedback from you. Hopefully positive. Anyways, I've mixed it up. So I can say analyze the lecturer feedback based on the following comma separated value ranking ratings. So if I ask now the system about this, if you ask the general model about this one, it will hopefully do something, but will far away from what you have, like in a custom way. So I have the script, the Python script, and I know that I expect this result, the sentiment analysis and the sentiment distribution, and so on and so on. So I get here that stats from the Python script. And as you can see here, it is calling the code interpretation. So it is creating a sandbox and is executing the Python code. So it's aware about that function or that script. And even more, I said that I have plotting, and the plotting is right away here. So I can also say, plot graphics for my better understanding, please, because we need to be polite with the AI. So if I say like this, I expect the model to, again, call the code interpretation, execute the Python script, and hopefully provide me back the graphic, which is more or less what I expect from this code here about the scatter plot and everything which is mentioned into the script. So basically, you can see here that I have got the sentiment feedback from attendees. I can also ask about pie chart because I know that I have that in the code. So I can say like provide me pie chart as well, and hopefully I will get a solution for that one. But you get the idea. So basically, I can search over my data, which is the retrieval augmented generation principle. Plus, I can also execute scripts using the agent and the tools that I'm defining right here. So yeah, I suppose that, yes, download sentiment feedback distribution pie chart. So it is executed and I can I can hopefully click and I can hopefully open it. And let me, showcase here. So there it is. It is creating that one. And just to mention that you can add in the knowledge different sources like Azure AI Search Indexes, Microsoft Fabric, TripAdvisor, and so on and so on. In the action part, you can add your script like the code interpretation, as well as OpenAPI 3.0 specified tool or custom function or even Azure function. When it comes to the Azure, I want just to showcase the process right now. So you can see that within this thread, that's the architecture of the agents. Now I have multiple runs, and each run has like different run step and tool calling. The first one for the file search, the others for the code interpretation. The file search is working with the Azure AI Index that I mentioned. So I will just briefly go to the Azure AI Search Service and showcase you that in the index, which is NextGen Heroes. If I ask what is Miodrag doing today, doing today, I expect here the chunks of data relevant to this question. So see, this is the data which is part of the index. So I'm using this data. This data is provided to the model to reason over the data. And there's also the confidence score. Let me go directly to this case, which I guess it's more even better for showcasing the orchestration. So now we know how to build an agent, and you can reference that agent. Let me show that. So if you go to the chat playground, a lot of people are asking me how I'm going to integrate with this one. There's something called view code here, and there's an integration with C#, JavaScript, and of course there's a documentation for the software development kit itself. But you can see that it's straight away like not more than 20 or 30 lines of code, so you can integrate with the agent and with the connection string. I'm going to delete the connection string details, so they will not be available if you try to connect to them after the session. But anyways, you got the point that you can connect to the agent. So now I know how to create an agent. Let's create multiple agents and do some stuff based on basic, on the well-known engineering principle. So I have this scenario, and I want to learn more about semantic kernel, and I want to start a bunch of agents to do that for me, to do the plan for me. I'm going to start this. This is the application in Visual Studio Code. It consists of the agents. It's the Explorer agent, Executor agent, the Planner agent, and also I have version 2 of the Executor agent, which is directly calling the Explorer agent. So this is where the handshaking is actually happening. And all of the agents, they have skills. In semantic kernel, we have skills. And each agent, you can guide each agent, configure each agent to specific parameters. So here you can see that they're minimized to use as minimal as possible tokens. And also, you can create different prompting for the agents and specialize them for different sources of data and so on and so on. So basically, I'm going to start this application. When I start this application, I guess that I will need the MongoDB. Yes. So you can see in the action plans that I have 6. Okay, I expect the 7 right now. So the application is started. This is the URL, and I'm going to Insomnia. So here on that URL, which is the same, yes, plan, the body is like, okay, I want to learn more about semantic kernel. Send. Okay, I know that I want to learn more about semantic kernel. And now I expect an haste prompt. So basically, see here, user confirmation, proposed and haste prompt. It is creating me a prompt based on my prompt and is asking me, is this acceptable? I've done this in the terminal. I can say no. It will go again try with additional prompt, but I will say right now yes in interest of time. So this prompt is considered, and then it is sent to the planner agent. So now the planner agent will take that prompt, will try to build, based on the Azure AI Search Index, will try to build a plan. You see here, creating a plan. And it will, I expect the plan to be created in the MongoDB under some correlation ID. So they're all work, by the way, with GPT-4o mini model. So basically, if I refresh now the screen here, yes, I have the 7 plan. So under this correlation ID, I have this user prompt, which is enhanced, and I have comprehensive action plan about how I should learn about semantic kernel. And this file is not processed still. So basically what's happening behind the scenes, you see, there is the application orchestrator, which is providing that plan to the executor agent. So now the executor agent is starting the process based on that correlation ID, and is trying to create, you see, execution plan. So if I go now to the execution results, there's 7 instances, and see here, there is the correlation ID, the same correlation ID, the execution plan. This is the execution plan, how I should learn, I should supposed to learn semantic kernel. And here is the feedback to the planner. It even provides back a feedback to the planner. And I expect now in the action plans, this variable to be true because it was processed, okay? And actually I have the execution feedback as a 7th instance into the database right away here. So that's the flow of the application. So basically what I've built, if I go to the execution results, I started with action plan. I started with, I started with this one. I want to learn more about semantic kernel. I end up with, I want to learn more about semantic kernel, blah, 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 a lot of blah, blah, blah related to it. And then I ended up with the execution results and detailed execution plan about how I should supposed to learn, with really minimalistic token frame and token availability to the provided to the model. That's the first demo, and then I will showcase the another one, which is this one. I guess this will be the most interesting part for you guys. So I have one application, specified one application, fitness application. I'm running, by the way. I'm trail runner, I'm runner. And you're not a runner if you not mention it. I'm mentioning it, I'm running, okay? So I'm going to open this and see. This is my application, nothing special. I mean, you're envisioning a web application for your run and trail logs, and this is like utopia for me. So I have a planner for my runs. I can track some parameters. I can see my history and so on and so on. So I want to provide this to a system and provide me back something like a web application. That's it. And I'm going to start this application just to showcase what's happening under the hood. This is the Conda environment. So it will start the application, and I've created a dashboard. I presented the dashboard of the global Azure. I fixed it a little bit. I'm not a front-end guy. I'm not a UI guy, so the dashboard is nothing special, but still, I love it. So I guess you will love it as well, and you will enjoy it. Anyways, so this is the dashboard. And I've created by my own. I'm really proud of it. So now, I want to put here the specification file. Let me find it. Index data. It's not the index data. It's in the demos. And it is here, spec data, and this is the fitness app. You are envisioning a fitness app, and so on and so on. And I'm going to start the process and see what's happening behind the scenes. So the specification agent is immediately running. It will create MD files about the output, and it will showcase here how many tokens the agent spent to do that specification. And as you can see, there's a log. So they are starting one by one. They are all orchestrated by semantic kernel, which is part of the Flask API application. And they, as you can see, run one after another. Take in mind the processing time. Pay attention to the processing time. So I'm not doing anything right now. I just have an idea, and I want to build something with different agents, which are, by the way, built with the semantic kernel, which is an open source framework for that. And as you can see here, we are spending like a lot of tokens. I suppose it will go around 30,000 or 35,000. Meanwhile, I will showcase that that's not a lot of money when it comes to the GPT-4o mini model, just to showcase that. So you can calculate that in the Azure calculator. So if I get the Azure OpenAI service, I can get this mini model. Let's say that we're going to spend like around 30 requests. It's like $0.02. So that's the spend if we have like approximately 30,000 inputs and outputs, which is more than I will use now in the application. I suppose it will be more, but still. So you can see that they are doing their job. They are logging the information here, and they are providing feedback. So here in the web application part, I have different. This is the web application part. This is the time trap for now. If I open, you can see the architecture right now. The specification is in the output. So I'm going to the specification part first of all. Yes, this is the specification. So you see, it's a fitness enthusiast. It's trying to understand the application. The specification agent is trying to understand the specification of the application itself. And then it is trying to create stories. Like, what should I include? So you see the Jira task. So I have the Jira tasks. So these are the functional requirements. And briefly just putting their story points, like it can be in t-shirt size, anything, but it is trying to estimate the stories and trying to do something like a functional requirements for the application. Then if I go back here, I have the architecture part, or the specification itself, and the architecture part. Here it is. So if I open the architecture, imagine that this is working with not more than 2,000, 3,000 tokens right now. So this is a minimalistic version of the framework I'm using right now, basically. So as you can see here, this is the architecture. So it is structuring the API request. It is providing the definition of the API request. You can see the database design in its general form and some scripts. And I will not lose a lot of time and go directly to the backend, which is a Python application. So if I open the backend, you will see the endpoints and you will see the logging and the actual service layer, the sessions, the commands and authentication authorization, and so on and so on. And the same is applicable for the front end in a nutshell. So you can see React components here. This is the application component. So you're for everybody familiar with the React, you can see and you can understand and you can realize that it's all about the React framework along the way. And let me see if everybody just, as you can see, they all finished. They spent 37,000, almost 38,000 tokens in 3 minutes. Not almost 4 minutes, okay? It is now just tracking the time when the application was started, but under approximately 3 minutes to generate everything of this. I'm going back to showcase just the DevOps pipeline, the Terraform scripts. You see that CI/CD pipeline, which is generated here. And that's all from the agents to the DevOps one. I'm going to stop the application and showcase you the prototype. So if now I have a prototype, which is also here in the index HTML. So if I open it right away, I'm going to bring the screen here. Okay, let me open it. Come on. So if I open the screen, there it is. So this is the prototype, okay? But it is really minified version of the prototype itself, okay? So this is with really limited scope of tokens, so that I have the application, my logs, I can log into the application, register to the application and stuff. So I can say like user and pass an email test like domain.com, register. So I'm now registration successful. I can say user and pass, and I can log in to the system, and I can track my times. Okay, I'm gonna say pace. I'm gonna say elevation, terrain rocky, weather sunny, doesn't matter, and add the log. And here is the log. Okay, this is the minified version. In the meantime, into the solution, there's the output architecture, the output directory, which is consists of the backend and frontend itself. Okay, so I have the backend and frontend. If I extend the scope of the agents, and if I run my framework as I'm using, so if I put the framework, if I increase the framework, I mean the token frame, I got the same application. Let me just find it. The same application like this, just to find it, because it should be somewhere here. So in the output, let me find it and showcase you how it looks like. The same application under same agents. So let me open this. That's data. It should be here. Yes, this is a prototype. Yes, so this is some dummy data that I put. This is the application that I got if I put like the token frame to 8 to 10,000 per agent. So you see the real deal right now. So this is an application that is coming from this one. Okay, this is the text, and this is the application. So I have the statistics as well here. So I can add the statistics. I can try if it is working. It should be. Yeah, I don't know why, but still. And I can log something, and I have the configuration panel, and I have my logs that I've run. And I also can edit them and do some stuff with them with the internet storage cache. So that's the real deal. I mean, you can generate an application out of just an idea, out of just a conversation with someone, out of just imagination of your mind by using multiple agents that are supposed to do different part of the application. So instead of like arming one agent with a lot of stuff that can be called and executed, I'm developing and specializing different agents that can work in different segments like front-end, back-end, DevOps, and so on, to do and to be specialized in that particular area. And moreover, you can have different model and configuration for each of the agent depending on the case. So if I go here to the source file and go to the agents, guys, there's a base agent. The base agent is like, let me close everything. If I open the base agent, it's like the fingerprint for all agents. Let me zoom it out. Okay, so it's the fingerprint. It's like a base class. It's the blueprint of the agent. So if I go to the specification agent, you can see that he's like he is a child of the base agent. I mean, he is the copy of the base agent. And here you can see that it is instructed to do a specific job. And even more, if we go to the configuration of the agents, I'm not going to go because I have the connection string and everything there. If you go to the configuration, I can configure each of them to work with different model depending on the use case I have. So for example, if you want to scan a code base or do a reflection, you'll probably need a model with a bigger token context or token frame to understand that. If you want to do something with the coding, then you need different model that's specialized on has more potential and benchmark is better on the benchmark for coding and so on and so on. But you got the idea. I'm sure you got the idea. Let me go to the presentation and just wrap it up with learnings and next steps. So guys, this is all about the functional calling and the structure outputs and how you can utilize this technology. Just I really hope you have opened your horizon about how you can really design such a system with multiple agents and think agentic in a way that you're going to be more performant, more efficient, and you're going to really get the most of out of your imagination. And this is about the semantic kernel itself. Probably we'll need a different session about to go more into the technicalities about the kernel itself, about how we plug and play different sources to the data, but still you got the idea. And there are different frameworks, like for example, Autogen. Autogen is another open source framework which is dealing with the orchestration, and that can create. It is established to build the systems for agents that can communicate between them. And there are also other frameworks like Llama Index, like LangChain, LangGraph that you can use to build your agent or agents or orchestra of agents if you want to communicate between them. I hope that you really like the session. I'm open to connect. I'm open for discussions. We can connect and discuss this stuff because I'm really passionate. And as I started the presentation, I'm hyped about it. And as I mentioned, this is the URL. This part of the presentation is part of the season of AI, the AI agent season, the fourth edition right now. Powered by Microsoft. You can go to the link. You can go to the fourth season. You can see the others the seasons, and of course you can ping me at any point of time so that we can discuss and after all think agentic. Thank you for your attention. Thank you for your time, and I'm open for a Q&A.
Well, this was a very amazing session, and I guess that everyone here that was present on this wonderful event today had the chance to see how it's like to build agents from scratch that will build a complete 3-layer app in a couple of minutes. So really, uh, I don't know how can I emphasize it in another way, but this is truly amazing.
Thank you,
So
guys.
I would like to ask a question that just popped in my mind. So while I was looking at the final results of all these agents, uh, I got the question in my head like, do you personally think that we're heading towards a time where coding means selecting and linking agents rather than just writing functions line by line?
Yeah, so basically, it's time where we can really utilize. It's like with every tool, every framework. It's time to utilize and to get the most of it. So we have the AI. We know how to build agents. So basically, at least we can use them to create the architecture, to give us suggestion about the architecture. At least we can utilize them for an idea about how you can structure the code, to debug the code, to write down the code, to create the baseline, the vanilla of it. But I don't think that it will completely change the development perspective, because you can have the code, you can have the vanilla code. I mean, you have the packages, but then there are different things that you need to do in terms of to check the packages, to check the code, to really see if that infrastructure which is provided by the agent is the infrastructure that you want to go, how much it costs, how you gonna scale it. So basically, I think that we are switching to we know the software. We should all know the fundamentals. I mean, for example, in the programming language, you need to know the object-oriented paradigm so you can deal with the code. Okay. So basically, we are using the technology to make us more efficient or performant, but still it needs the human touch in order to make it really valuable and to make it real after all.
Yeah, that's true, and I guess that we still need, as you said, the fundamentals in order to achieve all of this. So you need,
Yeah.
that starting point in technology that will guide you then through these kinds of wonderful solutions that you just have shown
Yeah,
us.
it
Exactly.
will, what
We
it will
sat
be, it
here
will
and
be the established baseline. It will be the established baselines for example, there are people that are not technical, okay? So they
Yeah.
want to have an agent
yeah,
or assistant. So we can build financial advisor. We can train or fine tune or use models that are used to that are supposed to do that thing. So basically, what the non-technical people will do is like they will inject to a system that will provide that functionality, and the system will say, okay, provide me your data, or tunnel your data, or inject your data, or connect me with your system. So basically, all of the technicalities will be done out of the box. Okay, so the end user will just experience the real value. That will be the more advanced reasoning and more advanced finding of information, or finding some clues or stats or building something. It's the same replicable with the code. With the code itself. So that's where the potential is right now. So that's what the models are capable of right now.
Yeah,
wonderful.
Marco, I think that you would agree with this, right?
Yeah, sure. I mean, me and Gwen were watching
Pilot,
the
pilot
show.
guy.
Yeah, and we are fascinated from what these agents are really capable of, and this is only the beginning of AI. I mean, 4 years of development, rapid development, and as you said, the popularity and the power of these agents will just exponentially grow. So it begs me to think like, what will be the world in 10 years? How powerful will these agents be? Will there be like one person companies, one person teams that control many agents? Will there be many more entrepreneurs that can build such ideas very easily, very fast? What's your opinion on how the future will be with all these
do,
agents?
do, do you think like years, or something that is like days or months?
Maybe it could be days. Yes, I
Yeah, I
mean
think
it
that everything you
totally.
mentioned, I'm just considering in just a matter of months, really. So
Really?
basically, the landscape is changing, guys. So a lot of as I presented, a lot of stuff is doing like in the AI ecosystem, in the agents ecosystem, and it's not just about us right now. So when I get back like 2 years ago, when I was discussing about retrieval augmented generation, there are all people just saying that. There are hallucinations. This is not it. It will not change the developers. But we are not talking about. We're not discussing that it will change the people. Okay, it's not that discussion. It's not the topic of the discussion. We're discussing how it can help us to inject it within an existing applications, especially when
Exactly.
dealing with NLP stuff, and how it can help us to make us more productive and make more efficient. So that's the ultimate goal after all. So everything you
Exactly.
said, I would say I'm just thinking in months or day or months, not years.
Wonderful. That's very interesting to hear. Also, for all of you watching, you can freely ask your questions, and we'll be here for the next couple of minutes waiting for you. But by our
Yeah,
side, I think this was a wonderful presentation. So yeah,
Thank
Bojan,
you, guys.
please.
yeah. We have some questions from the public.
Okay.
So there's a first question. So the person is asking if there's going to be set up for pay as you go for the Copilot agent. So how does that work, and can you show something about this aspect?
Yeah, I think that for the Copilot, you're the guys that you should do the presentation about the Copilot and everything in that world. Copilot is amazing. If you think about the Copilot itself, it's like different topic, different area, different product of the AI. I would really leave a space on the stage for Bojan and Marco, because they rock the stage on the Global Azure about the Copilot. We're gonna also make another session with them. So I guess it's more question for you than me, guys.
Well, I'll try to answer that. So basically, if you're using the Copilot agent, especially if we're talking about the GitHub Copilot agent, you'll firstly need an Azure. You'll firstly need a GitHub account, in which you would either buy that Copilot. I think it was $9.99 per month. But if you're a student like us, you'll have the chance to get it for free via the student developer pack, which is available on GitHub. You can just apply and then get the free subscription for GitHub Copilot, and then you can use it wherever you like, in whichever IDE or code editor you like. And basically, that's how the payment processing goes. I think I have covered it all. Marco, if you have something, you can also add.
Yeah, basically the pay-as-you-go plan is from Azure, not really from GitHub Copilot. So make sure you optimize GitHub Copilot, what resources it creates, so it doesn't burn the budget. So yeah, that's all from me.
Do we have anything else? I can see another one. Do you believe in the theory that AI will be more destructive than beneficial? I really believe in the beneficial part. So of course, I mean, not just the technology, every part of our life, you will agree that every part of our life has like both sides, destructive and the beneficial. I'm just thinking about how you can utilize and leverage and do something really impactful by looking through the prism of the beneficial one. So definitely, I believe that it will make more than we were used to do like 10 years ago or 5 years ago, and only through the beneficial point of view. Of course, the thing is destructive, or the pros and cons, it's a separate topic for discussion, and it could be like a matter of hours of discussion. That's really interesting and intriguing topic. But if I need to answer that in terms of the technical perspective and what I've done in this past like 2.5 years, definitely beneficial.
And I would like to end this session with I would say, a very beneficial question for all the students. So what can you say about the next generation of students that will deal with this AI stuff, basically us and also the guys that are coming after us? So what's your message to them?
Sorry, once again, well,
can you hear me?
can you hear? Yes,
Yeah.
yes. Now I can
Yeah.
hear.
I had a question about us
Yeah.
students. So basically, because this kind of AI thing and agents and stuff, it's pretty much new and it's pretty much fresh. So, what is your message to the students that want to learn this kind of technology and want to build their own agents?
So guys, just learn it. I mean, when I was like student, it was 2008, as far as I remember. Uh, this was sci-fi, guys. This was unbelievable. I mean, I think that we knew that something is coming, but this was like science fiction. So this is the window of opportunity that you need to use it. Okay, you have a lot of resources, you have a lot of platforms when you can connect with the people. So as I said, let's connect, let's discuss. The only thing to do something is to learn, and not just learn, as I mentioned into the demo. First of all, have a one. You need to want to you need to really to want to make an impact. Okay, you need to learn it, and you need to learn it on a right way. So connect to the people that they're doing that. Find the resources that will boost you. Okay, and use this window of opportunity to do some stuff with the technology. Now I'm not saying that it's easier because we have the agents. Now I think that the potential is higher in terms of the idea and how you can do some stuff. So I would say learn or make an action plan. Okay, so make a plan and then execute it, or learn it and do some stuff. And when it comes to the agent, my personal advice is like with everything I do. Read the theoretical part, just try to understand the fundamentals, and then try it by your own, and try it until you really make it, until you get the results that you've dream of before you started. So that would be my my advice. And I'm happy that just to wrap it up, that I'm happy that I had a great mentors along my career, and I think that the second part of the advice would be to find a mentor, find the people that are passionate about the technology, find the people that are willing that are willing to do this, not together but with the community. And that's the way to really build something extraordinary. That's the way to build something really impactful, and hopefully and to change the world for the better, for the beneficial part again.
That was a really inspiring answer, and I really hope that will be the case in the future. So, guys, again, thank you all for joining our 11th NextGen Heroes session today with our special guest Miodrag Cekic. And also, I personally believe that we'll continue this amazing special guest MVP sessions in the coming months. So get ready, and we'll have a very interesting event coming for June too. So I would say that be follow us on our media. So follow us on LinkedIn, on also on Teams. We have a lot of content coming for all of you, and also we'll see again every one of us in June. So until then, take care and goodbye for us. Bye.
Thank
See
you
you
guys
guys.
once
Bye,
again.
Mildred.
See you. Bye bye.